Alright, here we go. So final lesson on the polar graph stuff. The main focus on this lesson was to really be able to relate our sort of the Cartesian graph, the rectangular graph, with the polar graph. And there's a lot of questions that come up about these polar graphs that can be a little tricky, but when you see it in terms of just your normal XY grid, maybe that would help make a lot of sense. So we're going to graph this guy and then graph this guy using the same information that we got from here, just so you can see how it relates, and we're going to answer some questions along the way. But then the other thing was, there's sometimes when they give you part of a graph, and they want to know what interval was it created in. Was it a quad 1? Is it quad 2? Is it quad 3? Or they just give you some kind of limited domain like this, and they'll say what, which one of these domains does that graph represent. You're only getting part of the graph. So understanding the order in which these graphs are created and where they come from can also help answer those type of questions. So we're just going to start with these guys. So we're going to fill in some points on this. So I'll go through this part real quickly here. So let me use a pen to make it a little darker so you can see it. So remember, just your basic cosine graph. We always start by saying that the period is 2 pi over b. So in this case, it's going to be 2 pi over 2. I threw in some angles down here. You'll get a chance to copy those down here in a second. I'll show you why we did that. I'm just trying to save some video time. So we know the period of this is pi, right? And so from there we said let's always divide that by 4, just so that we can see what we're going to be counting by. What are the intervals that we would use, right? So if I'm counting by fourths, right, that's why these are the angles that we would be using. Of course, we're going to start at 0, but then it's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. So that's why we're counting by that. Let's throw those into the grid down below, and if you want, you can pause and kind of fill those in. So if that's a half, then my 1/4 is going to be right in the middle here. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and then 8/4. So those are the points. And if you think about how do you graph a cosine graph, remember a cosine graph starts at the amplitude. It doesn't start at the midline. So here's the midline or the origin, right? Think origin or think pole on this. So as we plot our first point, since my amplitude is 4, the cosine graph would start at 4. 1, 2, 3, 4. And then think about where it goes from there. So it's starting at 4. We know it goes back to the midline, back to 0. And then at the next point, it goes to -4. Back to 0. +4. Back to 0. -4. Back to 0. +4. So you see the obvious pattern to those numbers, and hopefully that sounds familiar to what we did in our previous lesson when we were talking about maximums and minimums and zeros. Notice this goes from a max to a 0, minimum, 0, max, 0, minimum, 0, maximum. So it follows that pattern every time. Let me get a rough sketch in here. Right? And so we're very familiar with the way the graph it gets laid out when we put it from left to right, but what if we go in the polar circular motion? How do we get those exact same values? Do keep in mind, we already know that this is going to be a rose because of what I see right here. Since it's an even number, I know I'm going to double that, and I'm going to say there are 4 petals. One thing that we talked about before is for a cosine graph, remember we said they always start on the axis. Right, so I have an even number of petals. I know it's going to start on the axis. If we were to kind of graph this on our own, we would look at that and say, okay, so let's go out to our petal length, which is 4. 1, 2, 3, 4, and that's where this guy would start. And we would say, okay, so here I got a petal here. There's 4 of them, so I got a petal here. I got one here, and I got one here. Right, so we already know what this graph's going to look like, but I want you to see the order in which this appears. Go off of these for a minute. Notice this started at the max. It started at 4, and then 0, negative 4, so let's fill those in. 0, negative 4, back to 0, back to 4, carry on that pattern, back to 0, negative 4, 0, 4. Right? So those are the points that we're plotting, but these go in order by angle. So we're traveling this way as we go through that. So my first one was at 4 and then 0 degrees. Then I'm going 0 at pi over 4, so at 0 radius. So as I approach pi fourths, my length is 0. So the graph started here, and that's important. I want you to know where these graphs start and then where they go next. So in the cosine graph, it starts here and then goes there. As I approach pi over 4, my radius is decreasing, and my relationship to the pole is decreasing as well. Right, I'm getting closer to the pole. As we go to the next point, so as I go from here to here, so now I'm going from pi fourths to pi over 2, where does our graph go? Now I'm at negative 4 pi over 2. So negative 4, and then travel pi over 2. Let's see, 3, 4, and we're here. So we just traveled from here to here as our next move. So here's one of the reasons I'm doing this lesson is you're going to get graphs like this where they only give you part of it, and they're going to ask you what interval was that graphed in, or what quadrant maybe was that graphed in. So all I've done so far is go from 0 to pi over 2. Well, from 0 to pi over 2, I get this. All right, that's the first part of the graph. What about from pi over 2 to pi? What are we getting? Also notice as you look at this, you are decreasing. So I decreased again. On this decrease, my distance to the origin is decreasing because I'm getting closer to it. But as I go to this part of the decrease, so I'm still decreasing, but now my distance to the origin is increasing because I'm getting farther from it. So keep that in mind as we go through. This really helps answer those types of questions as well. So where does it go next? Well, after you hit the minimum, so I'm at a minimum right now. After you hit a minimum, where does it always go? Back to 0. So now I'm back to 0. So there's the next part of the graph. After you go to 0, you go to a max. So at pi, I'm at a maximum of 4. So we went 4, and then pi, 1, 2, 3, 4, there's the next point on the graph. So you see the order in which this graph is appearing. Again, you'll get questions just like this, and it's going to ask you, okay, what interval does that represent? And so we want to know, well, that represents from 0 to pi is where I'm getting that interval of the graph. Keep going. From the max, we always go back to 0. So now I'm here. From 0, we go to the minimum. So at 3 pi over 2, I'm at a minimum of negative 4. So negative 4, and then travel 3 pi over 2, and now I'm here. So it's weird because that's actually a minimum. We don't think vertically, right? When you look at a polar graph, we don't think up and down for maximum and minimum. This you do, right? But this is not up and down. This is circular. And so you can't look at this and say, oh, well, it's a max because it's up here at the top. It's not. It actually represents a minimum. So our next move was to go from 0 to negative 4. And then we always go back to 0. And then you can see the final portion from here to here takes us back to a max right there. So I want you to see the order in which that appears, how those maximums and minimums and zeros play into this, and how we can relate this guy to this guy. So that's going to be the big point of this whole lesson. So let's keep going. I'm running through a bunch of examples here. I'm going to fit in as many as I can. On some of this, like any lesson, it's always a good idea to maybe even pause it and go through it on your own, give it a shot. So I'm going to do the same thing on this one. So let's go through here, let's fill in the points, and I'll go through this quickly. You can always pause if you need it to slow down or something like that. So period, I'm always doing 2 pi over b, so 2 pi over 3. I would divide that by 4. So that's going to be, what is that? It becomes 2 over 12, so 1 over 6. So my intervals are working by sixths. So 1/6, 2/6, 3/6, so on. So this would be, first one's always starting at 0. Second one is 1/6. And then 2/6, which would be pi thirds. And then 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, and 9/6. And we're not even going to need all these points. You'll see here in a second. Kind of another big point I want to point out for this this page. Okay. Remember what this would look like here. We already know this is a rose, 3 petals. It's cosine, so it starts on the axis. So I know that if this is symmetric, right, think about where those guys would play out. So I know every 120 degrees I get the next petal. So petal here, petal here. So I know that's where the 3 petals are going to go. Let's compare this guy to this guy, though. That's sort of the point of all this. So cosine graph starts at the amplitude of 4. Let me throw these into here. This would be a 6th. There's your 2/6, 3/6, 4/6, 5/6, 6/6. So I'm going to stop there for now. So you'll see where this is headed. Okay, first one, so starts at the amplitude, back to 0, amplitude, back to 0, amplitude, 0, amplitude, 0. You could keep going, right? So we already know the general look. And we know that could keep going. You'll get the idea. But I wanted you to see the pattern of the radii as we fill those in. So we know that the cosine starts at the amplitude up here at 4. And then what's the pattern? 0, -4, 0, 4, 0, -4, right? Max, 0, minimum, 0, max, 0, minimum. So we know that's the pattern that these play out. So you can fill these in real quick. Alright, but we may not need all those points. You'll see here in a second. So let's just start with this guy. So we know the cosine graph starts at 4, 0, 1, 2, 3, 4. And then where does it go? As I approach pi over 6, my graph is going back to 0. So it started at 4, and then goes to 0. From there, it's going to hit a minimum. So at -4, I need to travel pi thirds. So at -4, I need to travel pi thirds. So 1, 2, 3, 4. So this is where the graph goes next. Alright, so that's actually the first part of the graph. That's where it travels, from here to there. As you go from here, we got 0 pi over 2, so back to 0. So as I approach pi over 2, my graph is approaching 0. There's the next part of the graph. From there, I hit my max at 4. So remember, that guy was a minimum. So max, 0, minimum, 0. My next one's got to be a max. So 4, and then 2/3. So 1, 2, 3, 4. So that's where it goes next. Of course, we go from a max back to 0. And then we go back to a minimum. So notice on that, where did this end? We just completed a whole graph by ending here. So this guy, I only had to go from 0 to pi to get this entire graph. So was that the case on the one up above? I had to go all the way to here and get the entire graph on this one. So here's a rule we can get from this. If there's an even number of petals, you have to go from 0 to 2 pi to get them all. Right? I had to use the entire 2 pi to get that whole graph. I couldn't just stop at pi, I'd only have half the graph. However, if there's an odd number of petals, so this one only had 3 petals to it, if there's an odd number of petals, I only had to go to here. If I keep going, I'm just retracing my steps. Right? I would be back to 0, then I go to my max, and then 0. You're just tracing back over your same steps. So if there's an odd number of petals, you only have to go from 0 to pi. So super important that you recognize that, right? I only had to do there, right, up to that point in order to get the entire graph. All right, let's keep going. So sine graphs. So this page now is going to be dedicated to the sine graph. So remember with the cosine graphs, we already know that cosine graphs started in amplitude, right? So it started at, like, that's why it started out here on the axis. But where do sine graphs start? Sine graphs don't start on an amplitude. They start at 0. They start at the origin. They start at the midline, right, with graphs like this. As far as graphing on here first, again, we're going to say that the period is 2 pi over b, 2 pi over 2, so pi. Remember, this guy has an even number of petals. I know there's 4 of them, right, which means I'm going to need to graph this from 0 to 2 pi to get them all. So there's an even number of them, right? So I'm going to need all those points. So if I divide that by 4, that means I'm counting by fourths. So pi over 4 is going to be sort of each interval of points. So we're going to start at 0. I'm going to need pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, so I know it's going to end there based on what we just talked about. So think of how the order of the sine graph goes. So this guy's going to have a fourth, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. So for this one, we know the sine graphs start at the origin. They start at the midline. So, and then I'll travel to the amplitude. So we know it's 0, 4 max, 0, a minimum of -4, 0, max, 0, minimum, 0. All right, so we know that's the order that these travel in. So it starts at 0, 4, 0, -4, 0, 4, 0, -4, 0. So I know that's the sine graph. Let's fill in the radius pattern on this, starting at 0 because it's a sine graph, and then max, 0, minimum, 0, max, 0, minimum, 0, and we're good. So if we plot the points on here, and again, big part of this is I want you to see the order in which this graph occurs. It starts at 0, 0. It starts at the pole because it's a sine graph. Then we go to the max. So as I approach pi over 4, my radius is approaching 4. Right? So as I go from 0 to 4, I am increasing. My distance from the origin is increasing. As I go from here to here, so now I'm going back to 0. So now my numbers are decreasing. I'm approaching from 4 to 0. My distance from the origin is decreasing. Now we hit the minimum. So if I went -4 and then 3/4, let's see, we're going -4 and then 3/4. Now I'm over here. 1, 2. There's the next move. So to see the order on this, I'm going from 0 to the max, back to 0, to a minimum, so that's a minimum, back to 0, to a max, 4, 5 pi over 4, 1, 2, 3, 4, so there's our next move, back to 0, negative 4, 7/4, negative 4, 7/4, 1, 2, 3, 4, use a minimum, back to 0. So that's the order in which that graph occurs. So again, when you start seeing only part of this, like if they just said what part of the graph does that represent, you can always go back to this concept and lay it out and see the order in which things appear, and that will help you determine the intervals that you're looking at. This is a great way of looking at questions for increasing and decreasing. It's also a great way to see your relationship to the origin within intervals, right? Because it's my distance from the origin is an increasing, decreasing, increasing, decreasing, increasing, decreasing. So you see the distance from the origin, right? So here's the origin or the pole that we're seeing on that as well. So again, remember that because it was even, I know it was going from 0 to 2 pi. What if it's odd? So we know if it's odd, I'm only going to need to go from 0 to pi in order to capture this. Period is 2 pi over b. If I divide that by 4, both in my intervals, you already saw those angles from the previous page. So remember, that's like every little notch that you see on here is going to represent a sixth. So we know it starts at 0, and then it's going to travel pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Let's stop there. Alright, so throw in our radius. Remember on these guys, sine graphs start at the origin, starts at 0, then moves to the amplitude. So it starts at 0, max, 0, minimum, 0, max, 0. So, here's what we got on the sine curve. See how that relates to the points on this and the order in which they appear. So that's also why we're doing this. So started at 0, traveled to 4, back to 0, minimum, 0, max, 0, so on and so on and so on. Alright, so for this guy, remember this is a rose that's got 3 petals. We did say that there's a formula on where these guys begin. I forgot to mention this on the other one. They don't start at 0, right? As far as this guy is concerned. Where is the first leaf that you would see? So sorry, yes, it does start at 0, but then where does the first leaf occur? Cosines, they're out here. It's easy to see where they begin, but where does this guy begin? So how would we know that this occurred at pi over 6? Remember, when you talk about a rose, for the sine graph, we said there's a little formula. If you did pi over 2n, that's n, that tells you where the first petal will occur, right? So at pi over 6, I'm getting the first petal. So as I go to pi over 6, my radius is approaching 4, 1, 2, 4, and that's where we're going to get the first petal. So started at 0, started at the origin, then it went to here, back to 0, to the minimum, negative 4, pi over 2, 4. That was the next portion of the graph, back to 0, 4, 5 pi over 6, 4, 5 pi over 6, 1, 2, 3, 4. And that's the next portion of the graph, back to 0. And again, you see why I only have to go to pi when it's odd, and I'm still getting the entire graph. Okay, the last part of this is, what if it's not a rose? So I wanted to show you guys a couple of the other graphs that we talked about and how this concept still works with other types of graphs. Alright, so what are we seeing on this guy? Remember, this is in the form of a plus b cosine theta. So it's in that form right there. So I'm thinking it's one of our lemmasons. So is it a dent? Is it the dimple? I mean, is it the loop, cardioid? If a is less than b, then I know it's going to be the loop. I know it's a positive cosine, so I know my loops are going to be over here. Remember that when we added those together, we got the large radius. If I find their difference, I get the small radius. So just let me plot a couple points. I want to remind you of some things. So with the loop, we already kind of know where this is going to go. Right, I got my large radius at 4. 1, 2, 3, 4. I have the small radius at their difference, 1, 2. Remember we talked about the intercepts. That's according to your A values, so up 1 and down 1. So we have a pretty good idea of where this loop's going to, I got the small loop right here, I got the large loop, but in which order do they occur? And this is the important part of the lesson, because remember, sometimes you're only given part of the graph, and I want you to know what interval they might be giving you. So this is about determining quadrants and intervals that things are occurring. So where does a cosine graph start? Remember, this guy has a vertical shift of 1. Going here. With a cosine graph, so this guy is simply 2 pi over b. So the period is 2 pi. If I divide that by fourths, I am looking at intervals of 1/4. Sorry, 1/2. Right? So it's like it starts here, then goes here, then here, then here, then here. So cosine graph starts with the amplitude, so it's 3 above the midline. So 1, 2, 3. In other words, my starting point has a radius of 4 at 0 degrees, or 0 radians. My radius is 4 at 0 radians. So where would this graph begin? It begins at the large radius, at 4, 0. It starts here. Where does it go from there? So from there, we know we're going to go back to the midline. So this guy would be our next point. So if we look at that just as like an ordered pair, we now have a radius of 1 at pi over 2. So where are we seeing that on here? So if I went 1 pi over 2, that's this guy. So the graph started here, and then on the next move went to there. So there's like basically our first quadrant, right? So from 0 to pi over 2, quad 1, that's this part of the graph, is quadrant 1. Let's keep going. So from there, we now go below the midline, so 3 units below. So 1, 2, 3. So at pi, we have our radius down here at -2. So at -2 pi. So let's see where that goes. So if I went to -2 and then pi, we're right here. So next we're headed towards our small radius, right? So we're going to be heading to this one. So as we kind of carry through, you're going to start seeing the loop take place. So we're going to this guy. That's the next part. That was quad 2, from pi over 2 to pi. From there, we're going to go from this guy back to the midline. So at 3 pi over 2, we are back to a radius of 1. So we go back to our point where 3 pi over 2. So if I went 1 and then 3 pi over 2, I would be right there. So my next move goes like that. Poorly drawn. There we go. So my next move goes here. Guess where we're going on the final move, right? So at 2 pi, I'm back to my max of 4, which is right there. So to finish this one off, we're back here. So an ugly loop, sorry, but you get the idea. right? So I wanted you guys to see the order in which this goes. So cosine's going to start at the large radius, right? And then it works into the small loop, and then it finishes back to the large radius. So it's going large to small, and that makes sense because of what we're seeing on here, right? So our cosine graph starts up here at the large radius, and then it works down here towards the small radius at 1, and then back to the big radius. Alright, last one. Jump down to this guy. Always good if you're watching this for the first time to pause and try, right? You can plug these in, you can graph, and then sort of work your way through this one too if you want. But let's see. So on this one we have a sine graph that has been shifted up 4, so that's the midline, but I do have a reflection. So I wanted to show you one with a negative, because that definitely matters. So in this case, our midline is up here at 4. So right here at 4 is going to be our midline, right there at 4. So recognize this is 3, and recognize the one above it is 5. We're going to need those numbers. So that's good to know. The reflection is obviously going to play into this, so we'll see how that factors into this guy. So we know with our sine graphs start on the midline. So with this one, I know it will start at 4. So at 0 radians, my radius is 4. So on this one, and we're going to think about what kind of a shape is this, right? So if I were to travel 4 at 0, 1, 2, 3, 4, it's going to be my first point on the graph. So what kind of in general, we already should know what this looks like based on our previous lessons, right? So since A is bigger than B, I know it's going to be the dent or the dimple, right? So I'm expecting that kind of a look. So remember, that was kind of like, I'm terrible at drawing this stuff, but you'll get the idea, right? Something like this. So that's what we're expecting on this. This is a negative sine graph, right? So I know the large radius will be down here because it's a negative sine graph. I still look at their sum and their difference for the large radius and the small one. If I add those together, it's 5. 1, 2, 3, 4, 5. And remember, with these guys don't hit the origin. They go above it and below it. So my small radius, their difference is 3. 1, 2, 3. And just like I have one intercept over here at 4, according to this, I'll have another one over here at negative 4. So 1, 2, 3, 4. So we already know I'm basically taking this shape and I'm going to fit it into those 4 points. So we already know where the graph's going to go and what it looks like, but again, this is a focus on in which order does that occur. If they only give you part of the graph, I want you to know which interval this is referring to. So let's keep going on this. So where would be the next, or the first move on our sine graph is here, right? So we said that's where it starts. So where would the next one be? Well, if you keep going on your sine graph, where's it going to go next? So as you go to pi over 2, this is negative, my amplitude is 1, so I'm going to go down 1 to get to my next point. So at pi over 2, my radius is 3. And if we were to graph that, 1, 2, 3, and then travel pi over 2, so right there. So our next move on this, I'm not going to draw this very well, but I'm going to do my best, is right there. And then from there, where do we go? We go back to the midline. So at pi, my radius is back to 4. So again, if I travel 4 and then pi, I'm here. Here's my next move. Yeah, it's ugly already, and I haven't even finished it. Keep going. So we went from our 0 back to our minimum, back to a 0, back to a maximum. So we're going back up. So at 3 pi over 2, I'm now at my radius of 5. So if I were to go 5, and then 3 pi over 2, I'm here. So that's where it's headed next.